after we get to here, because all you've done is say, hey, the first two terms and the second two terms have a GCF. What do we do now from here? We got 1, first, 2, 3. Well, right now you have a GCF for this line. What can you take out of both halves? Yeah, and once you take that 2x minus 1 out, you're left with what? Now, as of this point, you actually can do two things. One is not mandatory, though. What could you do in the next step but isn't necessary? Do you need to? No. So I don't need to, so I'm going to sort of skip ahead. I'm going to go through and set each of my factors equal to 0. And by the way, when we're doing our work in this unit, don't say set them equal to 0. You should be getting two answers. Who can tell me what the one on the left would give us? We were to go through and solve that. Out? Yeah. Yeah, it comes out to be positive 1/2. You'd add the 1 divided by 2. You could actually write it out also. What would we get over here on the other side? Do me a favor, please, as long as we're all in this together. Go into your calculators right now and type that in the y equals graph in a standard window and watch what happens when you do that. Go in right now, please, and that's for all of you. That should be the most recent entry. Remember, you're never using scratch pad. Yes, I'll bring it in 1 second. The reason that you don't want to is you can't assign variables, and it loses things very easily. We're going to need to sort of say, hey, these are our constraints. Use these. Scratch pad doesn't allow you to use that. So go in and graph y equals 2x cubed minus x squared minus 8x and then plus 4. And let's see what we got so far. Oh, go in. Don't use the, well, you actually could check it by using that bar option. Here, if I go in right now, take a look. Here's someone's graph as it stands currently. Right now, I should know that the zeros of this graph, I can sort of eyeball it. It looks like they are at -2 and +2, and then it looks like it's at 1/2. Now, I can indeed verify that I get zeros at 2 and -2. How can you verify that there are zeros at 2 and at -2? How do you get the table? Go in right now. Please press Control-T and verify that, in fact, 2 gives you 1. Go up to -2. Okay? Now, this is actually something that comes up in AP Calc that we're going to be doing tomorrow. We can handle it today. So if I have you again in 2-ish more years, it'll be kind of easy. Take a look at what happens. Look at the output that you get at 0, and then look at the output you get at 1. I know that the graph crosses the x-axis between 0 and 1. Guaranteed. Why? Hands up if you can answer how you would guarantee the missing 0 is somewhere between 0 and 1. How do you know that our third missing 0 is between 0 and 1? What do you want to say? At 0, the output's positive. At 1, the output's negative. In order for us to go from a positive value to a negative value, what value do you have to hit? 0. And by the way, somewhere between these two values, the function also has to equal 3, 2, 1, 0, -1, and -2. It hits every one of those values between those two. Now, if you're taking your test, though, and you want to guarantee you get the zeros correct, go in right now, escape from the table. How can I find all 3 x-intercepts at once? Does anybody remember? I thought we did it in here. Do you recall? Go in right now, please, and go in. I think if you hit, does tab get you to the next? How do you get to F2? Tab, hit tab. Now, we need to graph y equals 0. So don't worry, the F2 is the same as y equals. Just put in a 0 there. Now, how can I hit all 3 of those at once? Intersection points, remember, go down. This is probably one of the few times we're going to use geometry. Go down to geometry. go over. We need points and lines and intersection points. Now, click on each of them, and don't make it so they're right on top of each other. Make sure I'm in an area where only the red graph is. I'm in an area where only the blue graph is. And once you click on them, we'll see it arrives at what those zeros are. Make sure, no, don't click on the points, because that's going to screw things up. Okay, now drag them away so you can see, and we should be able to verify that, in fact, this is what we go through and get. Do we have questions on that? You should be able to link this together. Now, one other thing, now we're dragging the wrong thing. When you do this out, so when we're doing this out, one thing that is important for you to understand, what happens at these values is significant as well. Notice that the graph is going through at those intercepts. That's not always going to be the case. It goes through at those intercepts. Actually, let's do this, and let's practice with this. See how we're in 1.1 now? Go to menu. Oh, sorry. Escape from menu, go to doc. Yep. Now, this is where I'm going to, you all, and don't, please, if I ask for your help, if someone could just say, hey, I'm good at this, instead of having like 20 people yell, it really helps. I don't know specifically how to drag the points. You're saying to move them like that. As I understand, if you hover over it, get the cursor to go over it, and then you hold it down, is that right? Or click down? Is that what happens? You have to get out of it and make sure it's not looking for the intersection point 2. Did you get it to happen? Okay, so is it one click down and you grabbed it, or no? Hold it. Okay. I don't know how to make the claw come up. You'll understand. I still have never actually used these calculators, which is why I will be stammering when I'm trying to give you prompts at times. So understand you may have better ways of doing things than mine. I'm an old person. I need one way to do things, and that's it. So if you have different ways, that's fabulous. We tend to show just the one that I know, but you can do things more than one way. Go and please and press the button that says doc. And even, by the way, the numbering of our file system is important. This is question, think of it this way, question 1, part 1. So anything that I'm doing with this question could be 1.1, and then if I need more space, I could use a 1.2 and so on. If I want to go, though, to a new problem, so this next problem is completely separate from our graph and everything else, you would go to insert, and I think it's even called new problems. Go down new, let's try problem. If I'm wrong, it's page. I think it's problem. There we go. So see how now it's 2.1 instead of 1.2? That means that everything we do will be contained, like for this question, should be in folders that start with a 2, if we're going to keep making documents as we go. This one up, what I wanted us to do, I can't remember what I was going to show us. What an idiot. Go back to 1.1. Was there something that I missed? Oh, sorry, go to 2.1 again. I was going to show you a graph. Now, how do I go to doc? I need to get a graph on here for 2. So does anybody know how I can do that? How do I insert a graph in this? Let's go in insert. Oh, insert then graph. How tough was that? Go to insert and then graph. Go in and graph y equals x squared. How many zeros does this graph have? Stop for a minute before you, because now you're getting to the point where there's a contradiction. How many zeros should this equation have? This equation should have 2 zeros. How do I know there should be 2 zeros? The degree is 2, except when I graph this out, how many times does this equal 0? Once. And it kind of has to go into y. Look at how this graph behaves. This graph has actually 1 0 twice. When does y equals x squared cross the x-axis? At what value? 0. If I solved x squared equals 0, I get plus or minus 0, which is the same answer twice. So if the answer shows up 2 times, it behaves differently than if the answer showed up once. Go back right now, slide over. I think you got to get your cursor. Go back to 1, 1. Those answers all showed up once. In 2, 2, that answer showed up twice. How can I figure out how many times the answer shows up based off of how the graph looks? Can anybody connect that? You can actually figure out how many times you're getting these answers based off of how the graph looks. That's your graph where it was 2x cubed and some change. Go back over to the other one where you're at 2, 2. That's the graph of y equals x squared. How is what happens at the zeros different between those graphs? Who's got an idea? How is the behavior at the 0 different here than it was in the graph that we did before? How was the behavior different, and what does that behavior mean? Yeah. What happens at the 0 here? Yeah. How many times does this graph hit the x-axis? Once. How is that 0 different than the ones we got on the last page? Well, yeah, that's kind of it. That plays into just because I picked a simple function. Look at what's there. How many times does this answer show up? Twice. Because if you've got y equals x squared, you set that equal to 0. If you take the square root of both sides, you get x equals plus or minus 0, which is 0 twice. Did you have? Nobody's got an idea as to how you can tell how many times the answer is? That's a property of it being just an easy plain old equation. She said something that's the key in there. It doesn't go through the axis. What does it do? Touches it. Does it go through? Go back to your other graph. How many times does this happen? Once, because it goes through. How many times does it equal 1/2? Once, because it goes through. And how many times does it equal 2? Once, because it goes through there. That's our concept for today, and that's pretty much it. If you can go through and understand that these pictures are telling you a story also, you're going to be in outstanding shape. Let's take a look. Now, we left off, what page were you guys on? 63? Okay, so let's start off. Let's try to break some of these down. We've got these big, giant polynomials, and I apologize. This unit, it's so computationally heavy. We keep doing similar stuff over and over again. It's not exactly the most exciting thing that we're going to go through and do, but we got to get it done and bang it out anyways. Looking at what's there, how could I start off to show that 2 is a solution to that equation? What could I do to show that 2 is a solution to that equation, or how could I show it? So I'm going to go through and I'm going to plug in, what would we say? So 2 to the 4th minus 2 to the 3rd minus 27 times 2 squared plus 25 times 2 plus 50. Now, if I'm doing that out, that's fine. I would never in a billion years see anyone type that in their calculator. Not at all. How would you type it in? Go back over to your screen, get yourself a new computational screen. So let's go in, get ourselves a brand new computational screen. Now, I hope that we would go to 3-1. So if you can, if you're not going to get a new page, go in. We'll be insert, and was it problem? Right? Okay, so we're going on to a new, there we go. Add calculator. Type in what ours is, in this case, whatever it was with the x's in it, and then do the bar for the substitution. So do x to the fourth. So the reason that I tell you that, it is so dumb. Dumb with a capital D, maybe 5 D's in the beginning, to miss one of these questions because of a sign error. This makes it like bumper bowling. You can't mess it up now. So, did that work? Yes or no? Looks like it verified it to me. This came out to be 0. So, we know that the graph goes through the point 2, 0 now, because we've established that when I plug a 2 in, I get a 0 as an output. What else do I know after I do that out? There's some other property that we know about this equation based off of what you stated up above. What else can we say besides we know the graph goes through 2, 0? If you don't know, go back and see what we listed out before. It shouldn't be that tough, and we should have more than one person who can make that connection. You've shown that when I plug in a 2, I get out a 0. What else do you know? Go back and look. We listed stuff out. We answered questions like this a bunch of times. Go back and take a peek. We got one of us. Got a big equation like that. We can establish a ton of stuff. Really, one person, 2 of us, even willing to give it a try, 3 of us. There you go. We know that x minus 2 is going to be a factor. If we don't know that, make sure you're getting there. Do we have questions on A? Find all the zeros of the equation. How many zeros are there going to be in question B? Ellen, what do you want to say? There's going to be 4 of them. So I go over to the side here and write out I've got 4 zeros. Now, by the way, what's one of them? What's one of them going to be? You've got 1 at x equals 2. That means I still need 3 of them. How can I go about finding the remaining 3? Yeah, do synthetic division with the x minus 2. So what value would you have on the outside? Now, what are your coefficients going to be going across? Okay, let's go through and do this out. And as we do it, Adam, what goes here? 1, and what will go here? 2. Keep going. Sarah S., what would you go through and have here? And here? And next one up, Raina, what would you have here? Good. And then here? From here, I put those together. I got negative 25 again. That gives me a negative 50 here and a 0 here. So as of right now, I have x minus 2 times what will give me back my original. What do I have to multiply the x minus 2 by to get back the original? Matthew, what would you go through and say?
X to the third plus x to the second minus 25 x minus 25.
How can I continue to break down, I guess, or find the remaining zeros? Because this one hopefully sets up nicely. Factor by grouping, what do you want to group out of the first 2 terms? And what's left? Keep going. And then? So in reality, what would this all the way break down to? Okay? So those are the zeros of it. Are all my factors quadratic or less? So what would we do after we did this? Linda, what do you do after you got everything factored down? Perfect. So now comes the hard part. You've got x minus 2, you've got x plus 1, and you've got x squared minus 25. That means I'm going to get answers at 2 and at -1 and at plus or minus 5. So I listed the 2 out. I got a -1, I've got a 5, and a -5. Do we have questions on that? All right. You can do one. And if you graphed it out, you could figure out what they were. There's one. I will ask you to. How does it want this? Function represents product of linear factors. So take a look at that first graph. Slide over to page 65. The graph that you're given there in 65, the first one up, we're going to connect now this graph to the x-intercepts and to the equation. Take a look at what's there to start. If you needed this one, might be a little bit clearer. What would our x-intercepts be for that graph? What do you want to say? So x equals 1, x equals 3, and x equals -2. What is a possible equation of this? Well, I'll even give it out as an f of x. In factored form, what would the f of x go through and look like? Ashley, what would you go through and say? Okay. And now there's one thing that we need. Because you don't have any extra points on the graph clearly stated, you have to put some a value in front. Because that could cause a vertical stretch or shrink. The only points we know for sure are our intercepts. Do we have questions on that one? Now this next one's going to be a little bit more interesting. Kenny, when you look at that, how many zeros do you see? Okay, why do you say 3? Well, list them out for me. Sorry. Now, something interesting, though, we do need to take account of. According to this, I listed it out. Does that graph behave like a y equals x cubed or cubic graph? There should be a disconnect there. What's not matching up? How do you know this should have more than 3 roots? Yeah. So if the ends are both going in the same direction, you know that the degree needs to be even. So what do we, what is hiding in plain sight in front of us that we need to make sure we say? Yeah, so how many times does that answer show up then? So right next to it, you're going to put an M2. That means it has a multiplicity of 2 or happens twice. And now, even well, and this is why I think I asked Kenny in the beginning how many zeros there are, you could say 3 and be right, and you could say 4 and be right. Because one of those answers shows up twice. Now looking at what's there, let's try to build up what that equation would be. Make it a F, so G here. We don't have another point on the graph, so obviously throw an A in front. What else is going to be in the equation of this G of X graph then? What would we have to throw in there? Meg, what do you want to say? No, just list out what your factors would be plain out. What do you want to say to start? Good. Now, one of those answers, though, shows up twice. So which one shows up twice? So square it. Is that tough? That was a state question. Wow. all of a sudden, I don't want to ruin it. Me showing you how easy this is makes the class average being an 89 less impressive. Because is it really that hard to be getting these right? Now, here's one that's going to be probably the most interesting. It has to do with its behavior over here. What are the zeros going to be here? I'm going to guess this is negative. Oh, it has to, okay, 1, 2, so x equals -2, x equals 1, and x equals 3. But something weird happens here also. Look at what happens sort of at that x minus 2. See how it goes and does this? You see that or no? Is that, I know that, I'm sorry if you forgot. Oh, you can clearly see that on your paper. Can you see that now up here, how it sort of bends in that area? If it shows up once, does it bend like that? No. If it shows up twice, does it bend like that? If it shows up twice, what would it do? Go back up. See how it goes through and curves? How many times do you think that happens? I'm going to put an M3 after it. You actually wouldn't get tested on something like that, and it has to do with little bits of quirkiness of the curvature itself. If I were doing this FG, so this would be h of x equals sum a, who can tell me what they think this equation would now go through and look like? Eric, what do you want to say? Okay. And? Outstanding. We have questions on that? Okay. Yeah, those are all of them. This has to do with multiplicity, even and odd. Kind of basic. Slide over to 67. I tried to make it somewhat cohesive so you could sort of see what's going on. So go through right now. How many equations are there? There's 4 of them. Does it match? No. All right, go through right now and see if you can give me out an equation for what you think those 4 equations would look like. List out your zeros and their multiplicity before you even start. And just so we're clear, because I don't want there to be any argument, take a look at those first 2. There's really only one part of this that would be open to interpretation. You could have also given a graph that has mostly these same characteristics. Did anybody give a graph, I guess it was different than this, or I'm putting something on there that maybe you don't need to? Oh, that was wrong here, sorry. So now it's actually correct. What would, take a look here, see how it's at -4? See how it goes through, but it's not a straight through? That's me projecting that it probably is showing up 3 times instead of once. The only thing we're guaranteed there is it doesn't show up an even number of times, because if it did, it would only touch there. If it shows up an even number of times it touches, If it's an odd number of times, it goes through. And the reason that I say, take a look at what's happening here and here, I think this is what happens when you have a multiplicity of 1, and that curve is what you get with the multiplicity of 3. With that in mind, you can give me the equation of this guy down in the bottom. Take a look at what's there. What would we want to go through and say for the one in the bottom right? Haley, you want to give it a try? Okay. That means if you multiplied everything together, what would the degree of the equation be? 4. Do the ends go in the same direction? Yes, they do, because your degree is even. By the way, we don't know what A's value is. You actually could find it if you knew any other point on the graph. But you do know that A would have to be positive. How about for the one in the bottoms there? Jared, what do you want to say for this guy over here? Yeah, it's either to the first or the third. Either one of those works. Questions on that?
Why is there?
See how it goes through like this point here? This guarantees it's only gonna, the only thing that we guarantee by having this without an A, if the A is not there, the only thing we know for sure is that it will cross the x-axis at those two spots. We don't know sort of like the scale factor, you know how like 2x squared, the intercepts are the same, just the shape of the graph changes, like it rises and falls quicker. So unless we know another point, I always ask you to throw an A in front. If you were given another point, you would just go through, once you got this equation here, you'd say, oh, well, this other point that we got, like this one here, looks like it's 0, 14. I could be wrong. I'd go back to the equation, plug that in for x and y to solve for A, and then use that as my A value. But we don't know that yet. And that is nitpicky. The state doesn't ask you to take it that far necessarily. The reason I'm asking you, you're going to be doing it next year in pre-calc anyways. I'd rather you learn it now the right way the first time.
So can you put like any letter there?
Yeah, normally we put in A, just an arbitrary multiplier. Okay? Take a look. What are the multiplicities of, state the zeros in their multiplicity. So take a look at A. Andrew, what would one of the zeros be? So if you need to, this is all we're doing, setting it to 0. And then setting each of our factors to 0, x plus 2 equals 0, and x minus 1 equals 0. So we get 1 at, negative 2. And Andrew, what would the other one be at? Negative 2, and x equals 1. Now let's state their multiplicities. What would you get? Nicholas, what do you want for your multiplicity here? And the other one? One that's going to be a little bit awkward is C. Why is it going to be a little bit awkward to find the zeros in C? Liv, what's awkward about finding the zeros in C? Or I guess that's harder than the other 3 examples.
It's like it doesn't have parentheses.
Yeah, we didn't factor it down yet. So guess what you get to do right now? Yeah, go factor it down. When you list that out, you do factor by grouping. Shockingly, this one works out to have a difference of squares in it. You get to this point. All of our answers have a multiplicity of 1. Please don't confuse the plus or minus 3 with introduction of multiplicity. Those are 2 different answers. Do we have questions on that, please? Maybe. Keep going. Oh, go in right now and go to page 69, do out number 5. What's part of this equation going to go through and look like if we were to start listing it out at least in factored form? Maybe. 3. Give it a try. If the 0 is at 2 with the multiplicity of 3, what would have to be in the equation? Great. Keep going. Times. Mhm. Outstanding. Absolutely perfect. And again, you'd have some arbitrary a in front, but, well, it says write a polynomial. So technically, we don't know any other points. You really don't even need the a in front. Did you write an equation that has those zeros that many times? Did you? Yeah. Now we've got to give the other part. What would the degree of this polynomial be? Hands up if you can tell me. If you multiplied everything out, what would the degree or highest exponent in the group end up being? It's going to be 20. How'd you know it's going to be 20? Yeah, our degree on this would be 20. Pretty much it. Yeah. So I don't know. That's why I took it away. Look at the prompt again, because it said write an equation. Or say it said, sorry, write a polynomial function that would have those zeros with the multiplicity. And if we don't fill something in, we're assuming a is 1, and it would still have satisfied the question. Okay? Unless it, I guess, don't put the a in there unless you're sort of looking for that extra point. We'll see. How about for 6? I know this is a little bit tough. Write the equation in standard form if those are the roots. So if we know that, we know we've got, maybe it'd be helpful if we gave it out as zeros. We've got a 0 at x equals 0. We've got one at radical 2. And we've got a 0 at x equals negative root 2. Who can tell me what would be in this? We did b of x on there. So let's name this c of x. What would have to be part of our c of x equation if those are the zeros? Think about what has to happen to get those as its answers. What would have to be in the actual equation in factored form? Yeah, one of them. A times x squared plus 2 times x. So close. What'd you say it was, x squared? What? You want to make a change? You get to decide which one. You want to do plus 2 or minus 2? As I'm listing that out, it's already in factored form. If I wanted to, could I go through and set each of the factors to 0? And if I did that, I'd get x equals 0. And then what would I get if I solved that one on the right? The plus or minus 2. If you had kept it as a plus, what would we have had in the answer? Hands up, please, if you can tell me what would have been in our answer if he had left it as x squared plus 2 instead of x squared minus 2. You'd have an I in there because you're taking the square root of a negative. Not that bad. Trying to think of what else we got. This is another thing that's a little bit important. Answers always show up in conjugate pairs, but we can go over that later. I'm trying to think of ones that we could do that would be a little bit confusing. Just the same one again. 1/2. Okay. So now here's the type of problem. Was it you that asked about the A? This is exactly what you were wondering about. Take a look at what's there. This is a third-degree polynomial equation. As we're going through, start off by stating out your zeros. This has a scale of 1, so you've got 1, 2, 3 zeros. Where are the zeros of this graph at? Hands up if you can tell me where any of the what any of the 3 zeros of this graph are on page 73. Go ahead. Okay. Okay. All right. So it looks like those are the zeros. Oh, what an idiot. I wrote it on the side. Okay. So that's our answer to the A part. What is it doing? There. Now, the next thing that you've got to do is write it out in factored form. So if those are the zeros, what would this be in factored form? Haley, what do you want to say? Mm-hmm. Okay. Great. Now, you're actually given one more data point. It tells you that f of -4 equals 54. Now they use the letter C, I use A. When we're going through and doing that, what's the coordinate that we're going to have to go through and use? It's giving you an ordered pair, even though it's not directly telling it to you. What other point do you have on the graph besides your zeros? Nope, not necessarily. Take a look. Giving you an ordered pair. Go ahead. No? We need a point. That means you're telling me numbers here. Well, yeah, remember, this means it goes through the point -4, -54. How can you use that to solve for the A? Well, this is a x value, and that's a y value. So instead of being f of x or y equals, this would be 54 equals A times -4 minus 2, -4 plus 1, and -4 plus 10. Can you multiply these numbers together? Can you? Yeah. Go in right now. Multiply all that together. Tell me what you get on that side, please. I don't have a calculator. You guys need to get this done quick as we're getting towards the end here. Well, it's 108, okay? So that's 108A. Divide both sides by 108. And now, what is A's actual value?
Also, the girls' varsity tennis match is postponed today and rescheduled for tomorrow. Contact coach regarding the update. Thank you.
So if you were giving out the equation, you'd rewrite it, except instead of putting an A there, what would you use? 1/2. All right? Now, yeah. Oh, it's -54. Sorry. I was a doof. -1/2. Thank you. Now, go back to the front just so I can see which homework to do for you guys. Which one is it? 8A. All right. Oh, I can use the model. Oh. Yeah. So 8A, I'll send out the answer key for you tonight. By the way, I don't think your class's quizzes are in yet. Is that right? Okay, I'll grade them for you and have them done soon. I think that's it. You did a good job today. Was the assessment tough? Okay, let's hope tomorrow you nail it as well. Have a great day, guys. You did a good job. Jared, thank you for catching that.